So, if you're trying to figure out engineering schools, maybe you're a student, maybe you're already working and thinking about what makes a program really solid, you've probably bumped into this acronym, ABET. But what is it really? I mean, beyond just a logo on a college website, why do people online sometimes freak out if a degree doesn't have it?
Today, we're really digging into ABET accreditation. We want to figure out what it is, why it matters so much for engineering education, and how it affects your career path and how programs actually keep getting better. We've got a mix of sources lined up, some overviews from engineering groups, academic papers looking deep into how programs improve, and yeah, even some real talk from places like Reddit, plus the official ABET guidelines.
Yeah, and it's interesting because ABET isn't just some rubber stamp. It's really woven into how engineering education works and what the profession expects. It's about making sure the quality is there, not just checking a box. That's kind of the key thing.
Okay, let's break that down. First things first, what is ABET? Fundamentally, you said nonprofit, non-governmental, and ISO certified. That sounds serious.
It is pretty serious. That ISO 9-hour-1.2015 certification, think of it like this. It means their own process for accrediting schools is up to a global standard for quality management. It shows they're rigorous about how they operate.
Okay.
And they don't just do, mechanical engineering. Their scope covers applied and natural science, computing, engineering, and engineering technology. It's pretty broad.
So accreditation itself, what does it mean for a program? Is it like a college ranking? Like this ABET school is better than that one?
No, not at all. That's a really important point. It's not a ranking. It just means the program meets the quality standards set by the profession itself. It's like a baseline.
Ah.
It's a verification that they meet the criteria. You either meet the standard or you don't. It's more binary than that.
Got it. So it's a yes or no on hitting those quality marks. That sounds like a huge job to maintain. Who actually sets these standards and does the checking?
It's a massive operation, really. You've got 35 member societies involved, like the big professional engineering organizations. And then there are over 2,200 volunteers.
Volunteers?
Really? Yeah, volunteers, experts from industry, professors from academia, people from government agencies. They form these commissions, like the EAC for engineering or the CAC for computing. And they're the ones doing the evaluations, bringing that real-world perspective.
Wow. Okay. So a huge volunteer engine driving this. Let's get practical then. Why should someone listening right now, maybe choosing a school or thinking about their career, actually care if a program has this ABET stamp? What's the real impact?
The impact is pretty significant. For the schools, yeah, it helps them recruit good students. But for you listening, think of it like a passport for your engineering career.
A passport? How so?
Well, it signals that your education meets a global standard. So if you want to work for a big multinational company or go to grad school overseas, that ABET accreditation means your degree is generally recognized. You don't have to jump through as many hoops to prove your qualifications. It offers that global competitiveness.
Okay, that makes sense. A universal standard.
Yeah.
So let's flip that. What happens if you don't have it? What are the immediate roadblocks someone might hit?
They can be pretty stark, honestly. First, the schools themselves might miss out on key federal research grants if they aren't accredited. That impacts resources, labs, everything.
Right. Less funding.
Exactly. But for the student, the big one is often professional licensure, becoming a professional engineer, a PE.
Yeah, the PE license.
In many U.S. states, you absolutely need an ABET accredited degree to even sit for the first exam, the Fundamentals of Engineering, or FE exam.
Oh, wow.
Without it, you might have to get years more work experience, maybe 8 years instead of 3 or 4, before you can even take the PE exam. Or you face this uphill battle proving your degree is equivalent. It's a major hurdle.
8 years difference. That's huge. And you mentioned Reddit earlier. I've seen some of those threads. People get pretty worked up about this. What did you see there?
Oh, yeah. The Reddit discussions are intense. You see people saying things like, don't walk, run away from a non-accredited program. Lots of stories about major companies, think like Shell or Boeing, having ABET accreditation as a hard requirement.
Even for internships.
Even for internships sometimes. We saw users strongly advising others to transfer if their program wasn't accredited, calling the degrees near worthless or a waste of money and time for certain career paths. It's a very strong sentiment in many engineering circles.
Ouch.
That's harsh. It is, but it reflects the reality in many parts of the job market. And it's not just jobs and licensure. It often matters for getting into grad school, too. So fundamentally, ABET acts as this quality signal. It says the program teaches relevant skills, meets standards. It doesn't directly measure, say, how good a specific professor is at lecturing.
Right. Teaching styles is different.
Exactly. But it focuses on whether the students are actually learning what they need to learn the outcomes and whether the program has solid processes in place.
Okay, but what about brand new programs? They can't possibly be accredited from day one, can they?
That's a really good point and an important exception. New programs can't get accredited until they've actually produced graduates.
Ah, okay.
So if you're in the very first cohort of a new engineering program, it won't be ABET accredited yet. Usually the school will say they're seeking or pursuing accreditation. Then, once the first class graduates, they go through the review, and if they pass, the accreditation can often be applied retroactively to that first graduating class.
Okay, that makes sense. So we know why it's important. Let's talk about how ABET ensures this quality. What's the actual framework? You mentioned it's not just a checklist. What are the core ideas?
Right. The basic idea, according to ABET, is that a good program has to produce graduates who are, ready for the job market and equipped to keep learning and growing in their careers.
Okay.
It really boils down to two key things: program educational objectives, or PEOs, and student outcomes, or SOs.
PEOs and SOs. What's the difference there?
PEOs are the big picture goals. What does the program expect its graduates to achieve a few years after graduation? Maybe things like becoming leaders in their field or innovating effectively. These have to align with the university's mission and what industry needs.
So long-term aspirations.
Exactly. Then the student outcomes, the SOs, are much more specific. These are the skills and knowledge students need to have by the time they graduate to be able to eventually meet those PEOs. Things like being able to design a system component, analyze data, work on a team, communicate effectively.
Got it. Skills they have at graduation.
Precisely. And ABET is really big on this being outcome-based. They focus less on what specific lectures are given and more on proving that students have actually learned and can do these things defined by the SOs.
That sounds like a much more practical approach. So when the ABET team comes to evaluate a program, what are the main areas they look at? You mentioned criteria.
Yeah, there are 8 main general criteria they use to evaluate the whole program ecosystem.
8. Okay, what are they?
Well, first is criterion 1, students. How are students admitted, advised, monitored? How does the program handle transfers and make sure students meet graduation requirements? Sometimes programs slip up here with, inconsistent advising or poor record keeping.
Okay, the student journey. Makes sense.
Then criterion 2, those program educational objectives we just talked about. Are they clearly defined? Are they reviewed regularly with input from, faculty, alumni, industry folks?
Right. The long-term goals.
Criterion 3, student outcomes. How well does the program define what students should be able to do upon graduation? And crucially, how do they measure these outcomes?
Measuring the skills. Okay.
That leads right into criterion 4. Continuous improvement. This is huge for ABET. How does the program use the data from measuring student outcomes to actually make the program better over time?
The feedback loop.
Exactly. Then criterion 5 is curriculum. Does it cover the required math, science, engineering topics, and general education? We can dig into that more.
Yeah, let's definitely circle back to curriculum. What else?
Criterion 6, faculty. Are there enough qualified faculty? Do they have opportunities for professional development? Do they have sufficient authority over the program?
Okay, the teaching staff.
Criterion 7, facilities. Are the labs, classrooms, equipment, and even library resources adequate for the program?
Physical resources.
And finally, criterion 8, institutional support. Does the program get the necessary support and resources from the university administration and the institution as a whole?
Wow, okay. That really covers everything from advising students to making sure the labs have updated equipment and the university is backing the program.
It's a very holistic review.
Yeah.
And on top of these general criteria, there are also specific program criteria for different disciplines. So what's required for electrical engineering might have some specific additions compared to, say, chemical engineering based on input from their respective professional societies.
Right, discipline-specific needs. Okay, let's zoom back in on criterion 5, the curriculum. What does ABET actually mandate there? How specific does it get?
It gets reasonably specific on the building blocks. For instance, it requires a minimum amount of college-level math and basic sciences, at least 30 semester credits, or roughly 25% of the total degree, whichever is less.
Okay, so solid science and math foundation.
Definitely. And then it requires what amounts to about 1.5 academic years focused on engineering science and engineering design, and they emphasize using modern engineering tools within that.
Modern tools, like specific software.
It could be software, simulation tools, modern lab equipment, things relevant to current practice.
And importantly, it also mandates a broad education component.
Ah, so not just the technical stuff.
Right. Humanities, social sciences. The idea is to produce well-rounded engineers who understand the societal context of their work, can communicate effectively, understand ethics, and so on.
That makes a lot of sense. What about that big final project, the capstone design? Is that part of this criterion? It sounds like a really core experience.
Absolutely. The capstone, or major design experience, is a cornerstone of Criterion 5. It's meant to be this culminating experience where students pull together everything they've learned.
So what does it have to involve?
Well, it has to be based on the knowledge and skills they picked up in their earlier courses. It needs to involve actual design, not just analysis, but creating a system, a component, a process.
Okay, real design work.
And it has to result in tangible artifacts. That could be a physical prototype, detailed engineering drawings, maybe a complex algorithm or simulation, something concrete.
Gotcha.
And here's a critical part. It must incorporate appropriate engineering standards and multiple realistic constraints.
Realistic constraints like what?
Things like cost, manufacturability, is it sustainable, what are the ethical implications, safety, social impact, maybe even political considerations. Students have to wrestle with these trade-offs just like practicing engineers do. This material is cheaper, but will it last? Or this design is efficient, but what's the environmental footprint?
So it forces them to think beyond just the pure technical solution.
Exactly. It's about preparing them for the complexities of real-world engineering. And these projects are typically done in teams, which also builds crucial collaboration skills. And finally, they have to present their work, usually through both a detailed written report and an oral presentation.
That sounds like a really intense but valuable experience.
Yeah.
Okay, let's shift to criterion 4, continuous improvement. You said this was really central. How does this actually work? Is there a model for it?
Yeah, it's absolutely central. The most common model you hear about is the PDCA cycle. Plan, Do, Check, Act, sometimes called the Shewhart cycle.
Plan, Do, Check, Act. Okay, break that down.
So, plan. You figure out what your objectives are and plan the processes to achieve them. For a university program, this means defining what students should learn, the SOs, and planning how you'll teach and assess that.
Okay, set the goals and the path.
Do. You implement the plan, teach the courses, run the labs, administer the assessments.
Carry it out.
Check. This is crucial. You monitor and measure what's happening. Did the students actually learn what you intended? This is where assessment data comes in: exam scores, project ratings, survey results. You compare the results against your objective.
Analyze the results.
And act. Based on what you found in the check phase, you take action. If students aren't mastering a particular skill, you figure out why and change something. Maybe modify a course, introduce a new lab, change prerequisites. Then the cycle starts over. You plan the change, do it, check if it worked, act again.
So it's a constant loop of refinement. It sounds like a lot of work for faculty and staff. Is it just an added burden, an extra cost?
Well, yes, definitely requires faculty time and effort. That's undeniable. But the idea is that not doing this, failing to identify and fix problems, is actually more costly in the long run. Think about it. If graduates aren't meeting industry needs, the program's reputation suffers, enrollment might drop, and fixing deep-seated problems later can be way more disruptive and expensive. So, using assessment data to improve learning proactively reduces the cost of failure, you could say. And this applies to making the assessment process itself efficient, too.
That makes sense. Investing time up front saves bigger headaches later. Do you have an example of a university putting this into practice effectively? You mentioned Austin Peay State University.
Yeah, Austin Peay's engineering technology department provides some really clear examples. One thing they did was implement a very systematic assessment cycle.
How did that work?
They set up a 3-year rotating schedule where they'd focus on assessing 2 specific student outcomes each year. This way, over 3 years, they comprehensively assessed all their SOs without trying to do everything all at once every single year.
Okay, manageable chunks.
Right, and the faculty were really committed. They had weekly working group meetings just focused on assessment, plus dedicated ABET faculty retreat meetings to really dive into the results and plan changes. It built this culture of ongoing review.
Dedication is key. I think you mentioned a story about calculators. How did assessment lead to a change there?
Yes, the calculator story. It's a great illustration. They noticed a performance indicator in an upper-level course. Students were scoring around 63% on problems requiring calculus application, but the target was 75%. That's a significant gap.
Yeah, that's a red flag.
Definitely. So they didn't just ignore it. Faculty, students, alumni, and their industrial advisory board, the IEB, they all discussed it. Why were students struggling to apply calculus later on?
And what was the outcome?
The consensus was that students needed better tools to visualize and work through complex calculus problems earlier. So the action they took was to require students to use TICAS computer algebra system calculators in the lower-level math courses. The idea was to help them master the application, not just the theory, right from the start.
Wow, so a specific tool requirement came directly out of assessment data. Any other examples like that?
Another one was around communication skills. Assessment showed students needed more practice with oral presentations. So they didn't just add one presentation at the end of the program. They systematically integrated oral presentations into a specific sophomore-level course, ENGT 2030, to ensure students got consistent practice and feedback early on.
So identifying a weakness and then embedding the solution into the curriculum, did they make bigger curriculum changes too?
Absolutely. Another strategy was regular, formal curriculum review. Faculty would periodically revise course descriptions, prerequisites, the whole flow. For example, in their manufacturing engineering technology program, they saw the industry was getting heavily automated.
Right, lots of robotics and automation now.
Exactly. So based on that trend and likely feedback, they moved a course on programmable logic controllers, PLCs, which are key in automation from being an elective to being a required course. They wanted to ensure all graduates had that critical skill.
That makes perfect sense, aligning the requirements with industry needs. How much did direct industry feedback play a role overall?
A huge role. They actively solicited feedback from regional companies and their IAB. For instance, there was a lot of talk about Industry 4.0, smart factories, IoT, data analytics, and manufacturing.
Yeah, that's a big buzzword.
Right. So based on that input, Austin P introduced a whole new elective course focused on industrial automation systems,
Right.
ENGT 4210, and they made an effort to weave Industry 4.0 concepts throughout other relevant courses in the curriculum. It shows how they connect faculty expertise, student outcomes, alumni experience, and industry needs in that continuous improvement loop. All four groups are involved.
That's a really dynamic picture. It's clear this isn't just paperwork. It's about actively shaping the program. Okay, so a university decides to go through this or needs its regular review. How long does this whole accreditation process actually take? It sounds intense.
It is intense, and it's definitely not quick. The typical timeline is around 20 months, nearly 2 years, from the initial request to the final decision.
20 months. Wow. What happens during that time?
Well, year one is about preparation and the initial interactions. The institution formally requests the review. ABET assigns a team of program evaluators, or PEVs. The program then has to submit a massive document called the Self-Study Report, the SSR.
The SSR, that's where they document how they meet all the criteria.
Exactly. It's incredibly detailed. Then the review team might provide some initial feedback, and eventually there's the on-site visit, usually ending with an exit meeting where they give preliminary findings.
Okay, so that's year one. What about year two?
Year two is more about the formal reporting and decision-making. The ABET team sends a draft statement outlining their findings to the institution. The institution gets a chance to respond, correct any factual errors, and address concerns. Then all that information goes to the relevant ABET commission, like the EAC for engineering. They make the final decision at their big summer commission meeting, typically in July.
And then the school finds out.
Yep. Notifications usually go out in August. So, yeah, it's a long, structured process.
You mentioned the self-study report. Preparing for that and the visit must be a huge undertaking. What's involved?
Oh, it's monumental. The SSR itself requires gathering and presenting evidence for every single aspect of every criterion. But beyond the report, they also have to prepare tons of supporting materials for the visit team to review.
Like what kind of material?
Things like course syllabi, examples of student work homework, exams, project reports, all linked to specific student outcomes. They need meeting minutes from committees that discussed curriculum changes or PEO reviews, faculty resumes, data showing assessment results and how they were used, evidence of those capstone projects reports, drawings, maybe even videos of prototypes, transcripts to show students are meeting curriculum requirements. It's about having documented proof for everything claimed in the SSR.
That's a mountain of evidence. Then the team actually comes to campus. What's that visit like?
It's usually a pretty packed 3 days. The team, again, volunteers, PEVs, and a team chair digs into everything. They'll verify what's in the SSR, definitely tour the labs, classrooms, and other facilities. But a huge part is the interviews.
Who do they talk to?
Pretty much everyone involved. Deans, department heads, faculty, both individually and in groups, support staff, current students, often randomly selected, and members of the program's industrial advisory board. They're trying to get a 360-degree view and see if the reality on the ground matches the documentation.
Trying to see if it all lines up. Okay, the visit happens, they leave. Then what? Is there a chance for the program to respond before the final verdict?
Yes, there's a crucial due process element. Right after the visit, the team leaves a preliminary report or statement. The institution usually has about 7 days to point out any purely factual errors in that statement.
Okay, correcting mistakes.
Right? Then, more significantly, they get a formal draft statement later, and they typically have 30 days to write a detailed response addressing any identified shortcomings, weaknesses, or deficiencies. They can provide clarification or additional evidence showing how they've already fixed or plan to fix the issues. That response goes with the team's report to the commission for the final decision.
So there's an opportunity to address concerns. When ABET looks at all these programs across the country, across the world even, what are some common areas where programs tend to struggle or fall short?
Consistency is key for ABET, so they do see recurring themes. A big one is often related to Criterion 2, the PEOs. Maybe the program doesn't have good documentation showing they actually review their PEOs regularly with input from alumni or industry, or they can't show how that feedback led to any changes.
So lack of documented process for the long-term goals.
Exactly. Another common one is with Criterion 3, student outcomes, and Criterion 4, continuous improvement. Sometimes the methods they use to assess student learning aren't really measuring the intended outcome effectively. Or they collect data, but they can't demonstrate how they use that data to make improvements. The closing the loop part is often tricky.
Not connecting assessment to action.
Right. Other things pop up too, like maybe not quite meeting the credit hour requirements for math, science, or engineering topics under Criterion 5. Or sometimes issues with Criterion 7. Facilities, maybe labs, have outdated or poorly maintained equipment that hinders students from achieving the outcomes.
Okay, so process, assessment, curriculum, facilities, those seem like key areas. Now, when the final decision comes down in August, what are the possible results? What do the different terms mean?
Okay, there are a few main accreditation actions. The best outcome is NGR Next General Review. This means the program basically passed with flying colors, no significant issues found, no deficiencies or weaknesses. Accreditation is granted, usually for 6 years until the next full review is due.
NGR. That's the goal. What if there are minor issues?
If there are no deficiencies, the most serious finding. But there are one or more weaknesses, meaning the program isn't fully meeting a criterion, but the potential impact isn't severe yet, they might get an IR interim report or 4 interim visit. This means accreditation is granted, but they have to submit a report, IR, or have another focused visit, IV, in about 2 years to show they've fixed those weaknesses.
Okay, so address the weaknesses and report back. What if the issues are more serious?
If the team finds one or more deficiencies, meaning a criterion is not being met, and this significantly compromises the program's quality, then the action might be SCR Show Cause Report or SCV Show Cause Visit. This is serious. Accreditation is typically extended for only 2 years, during which the program has to submit a report or host a visit to show cause why its accreditation shouldn't be terminated. They have to prove they've fixed the major problems.
Show cause. That sounds like you're on thin ice.
Pretty much. And the final possibility is NA, not to accredit. This means the commission determined the program just isn't in compliance with the criteria, and accreditation is denied or withdrawn.
Okay, so NGR is good. IRIV means fix some things, SCR-SCV is serious trouble, and NA is, well, not accredited. If a school wants to aim for that NGR and navigate this successfully, what are the key things they need to do?
Based on everything we've talked about, I'd say number 1 is strong leadership commitment from the top down, the dean, the president. This whole process takes resources and institutional will.
Gotta have buy-in.
Absolutely. Second, open and timely communication with the ABET visit team before, during, and after the visit is crucial. Avoid surprises. Be responsive.
Good communication.
Third, meticulously organize supporting materials. Remember that mountain of evidence. It needs to be easy for the reviewers to find what they need to verify compliance. Good organization makes a huge difference.
Get your paperwork in order.
Definitely. And finally, taking that due process response seriously. Provide prompt, thorough, and evidence-based responses to any concerns raised in the draft statement. It's their chance to make their case.
Yeah.
It really comes down to being proactive, organized, and demonstrating a genuine culture of quality and improvement.
This has been incredibly enlightening. It really paints a picture of ABET not just as an accreditor, but as a driver of quality across engineering education. It's clear why it matters, from, opening doors for graduates in the job market to pushing the programs themselves to constantly get better through that continuous improvement cycle.
Exactly. And it makes you wonder, doesn't it? How does this really rigorous, outcome-focused approach do more than just certify that someone's competent? Does it actually help build this culture of adaptation, of innovation within engineering? Ensuring engineers aren't just ready for today's problems, but are equipped to tackle the completely new challenges that are inevitably coming down the line. What kind of engineer does this whole system ultimately help create for the future?
That's a fascinating thought to end on, and maybe for everyone listening, it's worth considering. How could you apply some of these ideas that focus on outcomes, that Plando check act cycle, to your own work, your own learning, even if you're not going through a formal accreditation? Where can you build your own continuous improvement loop?